All right. We are now getting ready to complete our source catalog. Each team has a map, and they went through that map, found all the sources that they could, identified as many of those as they could using the radio source finder, have built up this table. This is a pretty extensive catalog. We have a lot going on here. Crowdsourcing across the various teams. So now what we have to do is measure the brightness of our sources at the frequency that we did our observation. You always do this when you're doing a source catalog for a couple reasons. One, it's a good consistency check. For many of these sources, in particular the ones that were circled, we have brightness information at various frequencies, including our own. You can read the estimate off here, about 1600 for this particular source. For this one here, we don't have a good estimate, but we do have one data point at our frequency, 1400, close enough. And this was 75 Jansky, so we can compare to that. So we measure our brightnesses, compare them to the archival brightnesses, just to make sure we're in the right ballpark. If they're widely discrepant, we probably have something misidentified. Now, most sources, they don't change in brightness with time, but some do. Active galactic nuclei, quasars. If you have a supermassive black hole at the core of a galaxy and its emission is nearby, close to the center, then its brightness can change from year to year. So the information you're collecting is actually valuable. Someone may, at some point, study that quasar or that AGN. They may say, how bright was it at the frequency that you observed at that time? And you may be the only person to look at it this year. And so you're collecting useful information. Okay, so how do we do this? Once we download our image, we upload it into Afterglow. I guess I'm going to use this image right here. It's of map 128. And we're going to do photometry just like we did before. So we have to go to settings, photometry. It's probably in the default settings for optical. So change the centroiding radius to 28, change the aperture to 28, the inner radius to 50, and the outer radius to 70. Those are the default parameters for radio. At some point, I'll add a button so you don't have to type that all in. Then back to Afterglow. And make sure you're on the photometry tab with the light bulb. And then you can start clicking on things. Puts down the aperture and annulus. And this is 606. What's this one? This one's 864. And so on. They may not all work if you have a funny shaped one. Well, that did work. 4,440. Very bright. When you're in here, you may choose to change the brightness and contrast. Sometimes going to mid-tone and hitting default gives you a little bit more definition. So maybe I actually want that spot. Let me delete this one. I'll try this spot. Anyway, you can collect brightness measurements. You go back to the source list, and over here on the right, we have an area for that. You put your sources here, your measured brightnesses. But remember, you're measuring this in noise source units. We took the data. When it was processed, it divided by the brightness of the noisemaker. So this is in units of your noisemaker. It's not a physically meaningful unit. It's just a stable unit, stable across hours and days. To calibrate it, we also have to do this for one of our calibration standards, SIG-A, the Crab, Taurus A, or 3C274, Virgo A. If available, we'll use the brightest of these. It's in map 68. So I'm going to go to Afterglow. I have map 68 in here somewhere. Here it is. There is Cygnus A, alphatometer it, 35,488 for this map. You'll have to do it. It changes over time. So you'll have to do it when your class does it. Now I've entered that here. We're going to use that same source to calibrate everything. So the same thing's been entered over and over. So we take the brightness of our source in noise source units, divide by the brightness of Cygnus in noise source units. Then we know what fraction of Cygnus A each of our sources are. Then we just multiply that by the known brightness of Cygnus A in Jansky's. We've done this before. You go to the radio calibration tool. You can upload your FITS image here, and it will set the frequency range and the date, set your source. Our source is Cygnus A, and these happen to be the correct frequency, so I know that it's 1592 Jansky's. So I've entered 1592.3 Jansky's here. And then to calibrate any particular one, it's what you measured divided by this, multiplied by that, and that's what goes in here. And you'll have all your sources in Jansky's. And if it's a circled source, you've already entered the brightness at our band, and that's been copied over here, and you can compare and contrast whenever that's available to see if your measurement's reasonable, and to see, in the case of AGN and quasars, if it's changed with time. Okay, that is it for this video.